Hello everyone. In this video, I'll be demonstrating how to write a Spotfire data function using Lead Discovery ChemCharts. The data function I'll be writing is called order by ID or order by identifier. And this video may make a little bit more sense if you understand first how that data function works. So I'll include a link to the video for the order by ID data function in the notes for this video. Now let's roll up our sleeves and write a data function. The authoring tools for data functions are found in the ChemCharts data functions visual. So let's go ahead and add one of those. Choose the data functions visual. And what you see appear initially are all of the existing data functions that have been pulled from the Git repository that I have configured. But since I want to write a new data function, I need to add the developer tab. So I right-click to open the context menu, add the developer tab, which appears down here. And when I click on the developer tab, I'm ready to write a new data function. When defining a new data function, I have the option of using an existing data function definition, one of the data functions loaded from a Git repository, or I can upload an existing data function definition file. And the advantage to those options are if you have an existing data function that already has a GUI defined that's close to what you have in mind, it's much easier to work from an existing data function. For this example, we're going to work from an empty data function definition. Now, I've mentioned data function definitions a couple of times now, so I should probably explain what I mean by that. People normally think of data functions in Spotfire as a Python or an R script that somehow modifies the state of the document, usually adding information in the form of columns or data tables. Glysade data functions are a superset of that, or I should say data function definitions. There's a set of general parameters that define how the data function is displayed in the data function visual and how it executes. But there are also these additional fields. The input fields, for example, is the definition of the GUI for the data function. The output fields defines the control that the user can view for data functions that have been added to the document. And there may actually be things like filter controls or just lists of input and output columns in the output field's control definition. And then the Python script itself, the thing that executes, is in the data function script field. And it's also optional but possible to define an iron Python script that will configure visuals or change the state of the application to be able to view the results of data functions after they've executed. So all those things together are included in the data function definition. Now that I've explained what a data function definition is, let's go ahead and set some of the general parameters for the data function that I'm creating, including the name and the description. And it's a good idea to include enough of a description for the user that they understand what the function of the data function is. And then we can select out the category. I'm going to put this in the general category in the data function definitions. And I'm going to make it easier for users to find this data function even if they don't know the name. Notice I can select the checkbox next to filter because this is fundamentally a filtering data function. And notice you see the filter tag appear up here when I go ahead and check the checkbox next to filter again. This is a live version of the GUI that modifies as I'm building the GUI up. So we're going to use that a little bit more in the next step. I'm not too worried about the version for now. This is the first version of the data function that I'm defining. The executor ID is already set to the C Python data function executor, so we don't need to change that. In the service name, I'm going to enter script. That means that I'm going to include the Python script inside of the data function definition itself. Now, it's possible to define data functions in a library that resides outside of the data function definition, but if I want to embed the Python in the data function definition itself, I simply name the service name as script. Now, this is a nice general data function that should be used in both Analyst and Web Player, so I'm going to leave both of those boxes checked. But for data functions where they only matter or they only have utility in either Analyst or Web Player, by unchecking one of these boxes, I can exclude it from the list that is displayed in the data function visual. I want the data function to operate on all data, so I'm not going to set a limit by. I'm going to leave that as none. The service URI in this case is the version of Python that's going to be executing the Python script. So I'm going to leave that as Glysade Python, even though we can define different versions of Python. Usually the Glysade Python is the one that you'd want to be able to use. And then the final couple of text areas here, the maximum number of output columns and the maximum number of output tables. Data functions need to have pre-declared spaces in which to write their results. So we need to specify the maximum number. Even if we're not going to use all of the slots that we're declaring, we need to specify how many areas in which we can write results from the data function. In this case, I know that I only really want one output column and that the results are going to go into the original input table. So I can set my maximum number of output columns to 1, maximum number of output tables to 0, and I'm all set. And for the update behavior, I want it to be automatic. If a document contains information links and the user reloads their data, I want that the results of the data function to update automatically, so I'm going to leave that radio button checked. Now let's move on to creating the input GUI for a data function. Now, the input GUI is going to need two controls: a column select, so the user can select out the column of identifiers on which they're filtering, and a text area to be able to paste in a set of identifiers used for the filtering. So let's go ahead and add our first control element to the GUI. And let's name the ID column. And you'll see why that's important later when we're defining the data function script. And the control type is going to be a column select box. So the user is going to be able to select their column of identifiers. The data type here refers to the information that's transmitted to the data function script. We'll get to that in a bit. We're going to add a validation rule that's required. And we're going to say must select column of unique identifiers. I guess I shouldn't have glossed over the label for this. So the label in this case, we want to tell the users to select ID column. So we have our validation rule. And we're also going to add a column filter because we are kind of presuming that the identifiers are going to be strings. We're going to put that validation rule on the column filter rule on the column so that only string type columns will appear in the column selector here. So now we can go ahead and add our text area in which the users can paste their list of identifiers used for the filtering. In this case, we're going to set the ID to identifiers. It's going to be a control of type text area. The data type transmitted to the script is going to be string, and we'll go through that toward the end. And let's change the text area height to 120 just to make it a little bit easier to paste in and see the values inside of the GUI control. Now that our GUI has been defined, we can move on to the output fields. The output fields allows us to define an output control that once a data function has been added to a document, gives users some information about the inputs and outputs from the data function. So because this data function is relatively simple, we really only want to show two pieces of information: what the input column was that the user selected and what the output column was from the data function. So let's go ahead and add the first input field. In this case, source input field is appropriate. We want to select the identifier of the control in the GUI, so the input column select, the column containing the unique identifiers, and our ID for that GUI control was ID column, and we can say ID column in the label. Now let's add one more output field, and we're going to use this to display the output column from the data function. And since the data function only outputs one column, the choice is very simple. This is the first column that's output from the data function, and we'll call this output column. Now we can move on to defining the data function script. The blank area under the data function script tab is a text area in which we can paste our data function Python script. Now, we don't recommend doing development this way because the text area is not a proper Python editor. It's better to use a Python IDE for developing the data function script. And I'll show you that in just a second. I would like to point out just a couple of things in this script. You can see identifiers here. That's the ID of the corresponding control in the GUI that we defined earlier, where the user can paste in the list of identifiers used for sorting and filtering. And also the ID column identifier. So that's how to retrieve the contents of the column containing the unique identifiers that the user selects in the GUI before running the data function. So the IDs in the GUI control correspond directly to elements in the data function script that will ultimately be executed. Now let's move on to the IronPython visual configuration script. Visual configuration scripts are entirely optional in data function definitions, but they can be a very handy way to help the users to view the results of data functions either by automatically configuring visuals or altering the state of the document to be able to take advantage of the output from data functions. Now, I already have an IronPython script defined for my order by ID data function, and while I won't go all through all of the details, I will simply point out that if a certain visual type exists on a certain page, I can set the sort order for the output column that was created by the data function. And I can also set the filter type for the output from the data function in this section of the script. Now, I'm changing the filter type to a range filter because the range filter has an option to either include or exclude empty values. And since I expect the output column from my data function to contain many empty values that I'd like to exclude, if I set the filter on the output column to a range filter, I can simply exclude all of those empty values simply by leaving the include empty set to false on the filter itself. Now let's move on to exporting the contents of the data function definition such that we can develop the data function script in a proper Python IDE. When writing a new data function or even modifying an existing data function, we recommend working outside of Spotfire and using instead a Python IDE like Visual Studio Code or PyCharm. And we'd like to work with example data exactly like the data functions would execute when running inside of Spotfire. So to do that, let's go back to the input fields and remember this is a live GUI for our data function. So I'm going to select out my column containing identifiers, that's my code column. I'm going to paste in a list of identifiers that I want to use for filtering and sorting. And then I'm going to click the Finish button. Now, I've got a couple of options on this dialog. The first is the maximum number of rows to be exported to be used for test data. In this case, 100 rows will suffice just fine. And the other option I have to decide is whether to generate a new data function definition ID. So all data function definitions have to have a unique GUID associated with them. So if you are going to modify an existing data function definition, then you do not want to generate a new data function definition ID. If you're writing a brand new data function definition from scratch, you can allow the system to automatically create an ID for you. Then all you have to do is choose an output directory, and in this case I have a dedicated output directory. And now my data function definition, my initial script, and a script to open up PyCharm have all been exported from Spotfire. Here I'm showing the contents of the directory that was just exported from Spotfire. If I want to develop my data function Python script, I can double-click on the pycharm.bat executable, and that opens up PyCharm with my project. And you can see this is the Python script that I had pasted into the data function definition. I have my in.json file or input data that was exported from the live Spotfire document from which I was working. And if I want to execute this script with the input data in the in.json file, I can simply switch to the main.py Python script, say run, click on main, and now I've executed my Python script. So this is where you'd want to do your iterative debugging, working on data exactly as it would be transported from Spotfire to a data function for execution. And when the script is working, it will also generate an output JSON file that can be inspected for correctness of formatting. So once that is all complete, the data function definition file can be reassembled and tested live inside of Spotfire. This concludes our tutorial on writing data functions in Spotfire using Lead Discovery ChemCharts. If you have any comments or questions, please direct them to business@glysade.com, and thanks for watching.